There we go. Well, good morning, everybody. Welcome to this edition of WRLA's webinar, which will be focused on trusses and what you don't know can hurt you. I'm very pleased today to introduce to you Dave Pasoli, who's the Executive Director of the Western Truss Association of Alberta. Dave has been involved in the manufactured wood components industry since 1985. He spent 19 years in various locations with large engineered wood component manufacturer. In 2005, Dave took over as executive director of the Western Truss Association of Alberta. This association was formed in 1983. It currently has 32 truss fabricating plants that are members, plus numerous companies closely associated with the truss manufacturers of associate members. WWTA Alberta is a charter member of the Canadian Wood Truss Association and a partner of the Canadian Wood Council in the Woodworks program and an affiliated member of TIPC. So Dave is going to walk us through a truss presentation. We certainly have had some requests to talk about some of the best practices, quality assurance pieces, and I'm really happy to be able to pass the baton over to Dave. Just to give you a heads up, we will be taking questions at the end. So if you have a question that pops up, please use the chat. We'll be monitoring that piece, and then we'll make sure that we can get to the Q&A at the end of the session so that any questions you have can be addressed. So Dave, welcome, and I'm going to pass it over to you.
Okay, thanks, Liz. It's a pleasure to be here from snowy Calgary today. So I'm just going to get my screen going here. So you can, oops. So you can see that now? Let's get this off of there.
We sure can.
Okay. So once again, thanks for having me. My name's Dave Pasoli from the Western Truss Association, Alberta. Like Liz says, we're a voluntary association that was founded in '85. We currently have about 34 truss manufacturers in the province of Alberta that are members. So a couple more new ones since I wrote that note to Liz. We're pretty big users of wood in Alberta. We use almost 100 million board feet of lumber per year and employ about 1,600 Albertans. So all kinds of truss plants throughout the province. As Liz mentioned, we're also a member of the Canadian Wood Truss Association. So I know all of you might not be from Alberta. So in the Canadian Wood Truss Association, there's the BC Association, us in Alberta. Saskatchewan, Manitoba is one association. There's Ontario Structural Wood Association. Quebec is MSBQ, and then there's an Atlantic Association. So there's 6 regional associations in Canada of basically truss manufacturers, all that fall under the Canadian Wood Truss Association. So this morning, what I want to quickly talk about is just a little bit about how a truss plant works, and kind of stress the sophistication and the requirements of a truss plant. A little bit about choosing truss fabricator if you're a retail company that might buy trusses, some supply chain issues and reselling trusses, and then finally a little bit about some of the things that you have to be wary about and what can go wrong with truss installation. So I'm going to get going on that. So basically how a truss plant works, truss plants have been around since the early 70s. But it has grown in sophistication and technological advances over the years. But basically the kind of flow chart is there's usually a sales team, a design team that's a critical portion of being a truss plant. I'll talk a little bit about lumber and metal connector plates, sawing that's advanced quite a bit over the years, assembly, and the quality control requirements, a little bit about handling and storage, and then finally shipping. So as I mentioned, sales and design, when it comes to a truss plant, basically when you're dealing with trusses, every job is different. Even if it's the same house, they might have a different location, might have different loads that's different. Some customers will have different expectations about what their requirement and what the details they want. Building codes, of course, are different provincially, as well as there's also variances in what authorities having jurisdictions might want to require in designs and submissions and things like that. So building designers also may have their own requirements of what they want and specify, especially when it comes to supplying commercial or Part 4 trusses. Typically, truss plants also sell other products. Some are both lumberyards and truss plants. Most truss plants also are big resellers of engineered wood products. It is important to keep in mind that although there is a big design component of a truss plants are not building designers. They're typically component manufacturers, so they're not experts, or they might be experts in designing floor and roof systems, but they're not building designers, and that's what we want to keep in mind. And we also, designers and all the software has to follow standards that are developed by an organization called TPIC, which is the Truss Plate Institute of Canada, which we all work on, and we're a member of TPIC as well too, and we're involved in developing the standards for trusses. A little bit about lumber and metal connector plates. So lumber, like we basically design trusses with specific grades of lumber in mind, depending on what the characteristics of that truss need to be and what the strength characteristics are. The minimum lumber in trusses is number 2. We are the biggest users of the different strengths of MSR lumber from 1650 up to 2400. Although we use lumber based on the design characteristics for the grade, buying lumber on the open market, there is a fair amount of lumber that isn't acceptable in a truss plant based on their quality standards that we have to deal with. When it comes to the metal connector plates, the metal connector plates are all designed according to a CSA standard, actually 347, and as I mentioned, TPIC. So the metal connector plates are typically supplied by about 3 different companies in Canada. And the big thing with the connector plates that's very integral to what they're tied to is the software design. So basically the connector plate people like Mytech and Alpine and Simpson Strong Tie sell the metal connector plates. That's how they get paid. But most of what their services actually comes with the design and the design software. So just quickly go through a truss plant after you get the lumber, and you have to saw it. So there's various different types of saws that the companies use based on kind of what kind of business they're in. This is just a picture of what we call a linear saw that picks one piece of lumber at a time, runs it through the saw, and like I say, it's driven completely by the software. Very good for trusses these days that have to for companies that supply residential construction where you have a lot of different types of trusses. So these types of trusses are very accurate. They've come a long way from the pole saws that we used to use even 15 years ago. So a saw like this in a setup at a truss plant might be like $500,000 to $700,000 investment for the truss plant. So they're quite sophisticated and quite accurate. That being said, when it comes to assembly of trusses, it's still quite a manual thing of taking the lumber that's cut and then attaching the connector plates, and then the plates are pressed through some kind of gantry process typically. And this is really where the QC comes in. The actual tolerances from TPIC that most truss plants use are actually that plate has to be placed within a 1/4 inch and 5-degree rotation. And that's because the software is so accurate in minimizing the amount of steel that goes in that truss, of course, to reduce the cost of that truss. So, of course, the tolerances come down are quite tight as well, too. So, So truss plants have got very good at placing the plates. A lot of them have laser systems and automatic jigging systems within the plants to produce an accurate truss. But that's the most important quality issue that we talk about. So here's just an example of a joint detail for a plate. And I took a video of the software that designed that plate, and I'm just going to run it for you. And you can see how the software designed that plate to be in that specific location. This is the blow up for the plate. And if the designer just moves that plate a little bit, you can see how even moving that plate a quarter of an inch uh, makes less effective teeth into this thing here. So that's how accurate those plates have to be placed when you're manufacturing trusses. And of course, like I said, with the quality lumber, you have to also worry about plates over defects like wane and knots and things like that. Here's just an example of a plate going over at a heel joint in a truss where the top cord had some wane in it that made those teeth that are kind of outlined in the with the black jiffy there ineffective because they're not going into any wood. So you have to be able to accommodate that through a QC process to make sure that that plate still has enough effective teeth, or else upsize the plate to make sure it has enough effective teeth. So that's part of a quality management system. In trusses, we rely heavily when it comes to quality control on internal inspection procedures. So unlike a product that is made and meets a quality standard like the hockey helmet in the picture there, you make it once, you pass the standard, and then you just have to make it the same all the time. When you're manufacturing trusses, every truss is different, even though it might be the same type of truss. They may has the potential for different defects and different quality control issues like plate placement and that. So we rely heavily on an inspection process to ensure quality control in a plant. Handling and storage is a big thing in the plant. So quite often trusses can be big. Here's an example of a truss that was it was actually a 70-foot truss that was somebody tried to move with one forklift, and of course it bent and broke the truss. Here's the damage it did at the top cord connection. So handling trusses, especially big trusses, you have to have the right equipment to handle them and move them around. Shipping and delivery, same thing with especially with big trusses. It's important to have the right equipment. A lot of the big trusses that get delivered today have a roller deck thing like this to deliver the trusses to roll them off. If you don't have the right equipment, unloading on site can be a big hassle. There was one site delivered to a colony where there was some 80-foot mono trusses delivered just on a flat deck truck, and they had enough people there that they decided to unload them one at a time by unstrapping them and hand bombing them off the trusses, and so it can also be quite a dangerous process. Also for delivery, especially when you're delivering long loads, that might need permits or anything. If you do even break one truss, it's very expensive to ship one 90-foot truss to replace one that was broken. So it's very important that they're kept well at the site and no damage during delivery. So just want to quickly talk about choosing a truss fabricator, and this is one of my favorite quotes um, from John Glenn. As I hurtled through space, one thought kept crossing my mind: every part of this rocket was supplied by the lowest bidder. And certainly in our industry and your industry too, all about the lowest bidder. And typically, in order to get the lowest bid, it's not a matter of just reducing your margin to be cheaper. It's usually a matter of of reducing something to actually make the product cheaper. So you must keep in mind that not all truss plants are the same. We have members that are very small truss plants. I think our smallest member is a husband and wife and their children, and they have a small table and they do a great job building trusses and things, but they're certainly not very automated or have the investment in technology. But they can build out for houses and garages and shops and things that like that. They do a very good jobs. And then we go all the range to quite large companies that have a lot of technology, like the sawing and like the picture shows here of a laser system to place the plates accurately, that can afford to make that investment in that type of technology. So there's all kinds of truss plants. The quality requirements are the same, though, as set out by TPIC for tolerances and that. And plants that are a member of our association or the other regional associations must have a um, must meet a quality standard and have a quality management system to ensure that they're making uh, trusses that meet the right tolerances. So when you're thinking about truss plants, do think that they are not all the same, and somebody that's primarily in the residential or the housing market business might not be the best supplier for a 100-foot farm truss, and vice versa, because their productions is set up to do whatever their business is. Although there are a lot of truss plants that can do everything from a 20-foot garage truss to a 100-foot farm truss and all the houses in between. But when you are choosing supplier, you should know kind of what that company's business is, and especially when it comes to very large span trusses, there are a select number that really do a good job and are set up to do it. So quality control, as I mentioned, is very important. So here's a picture where, just human error has left a plate off one side of the truss. So it is a requirement that there be a plate on both sides of the trusses. So obviously that's a quality assurance issue. And like I said, any plant with a regional association like ours should be able to provide you with their assurance of quality through their plant number on the stamp on their trusses, or be able to provide that for you. I did want to talk just a little bit about floor trusses. Some trusses or some truss companies do manufacture what we call a 4x2 floor truss, which is a good alternative to the I-joist systems out there. It can be, of course, locally manufactured. So in the pandemic years, when there was a lot of supply chain issues, a lot of builders chose to go to floor trusses because they weren't having the issues with not being able to get engineered wood, I-joist, and things like that. It's also a better utilization of wood. So as I mentioned, when you're cutting the lumber and you take the stuff that might not be acceptable to go into a roof truss, you can cut it into shorter pieces, which of course can then go into floor trusses because they have a lot shorter webs. They are, very precision for the house that you're building, have a wide surface and can often provide better floor performance. So, when you're looking at systems, more and more builders, like I said, with the supply chain issues that we had, we're able to switch to floor trusses, and liked it so much that they've just kept doing it. Now, not all truss manufacturers make floor trusses, but those that do, it's a very good alternative that you might want to look at. Other than that, like I mentioned, truss manufacturers can go anything from residential. So these days, residential construction can be very complicated. It's not uncommon for not too big a house to have 40, 50, 60 different types of trusses or designs of trusses in a house. So those companies that are in the residential business are very good at changing setups and making packages of trusses where you might not have 50 trusses all the same type. You might have 50 trusses that are all a different type. Commercial wood trusses are very good alternative for commercial construction. Here's a picture of a wood truss being installed in a golf clubhouse. When it comes to commercial construction, one thing to keep in mind is there's a lot more emphasis that because it's a Part 4 building, that you have to deal with building designers and project engineers versus a Part 9 building, which might not have any professional involvement on the building design. So some companies do a very good job at commercial construction because they know all the requirements of that business, not only what the building code requirements are, but dealing with the professional engineers and the building designers. And of course, the other big application is agricultural or farm buildings. Again, those tend to be quite large buildings, and some truss plants are very good at producing those types of trusses that aren't as complicated. You might have one big building with only one type of truss, so it's making the same truss over and over again, but there's a lot of issues that come with those big trusses. So again, especially when it comes to commercial jobs, tendering and pricing are very important, and there's a lot of work, a lot of details that have to be worked out, including more and more what engineering services are provided and who provides them. For example, some engineers are requiring that the manufacturer do a field review now, so you have to deal with that, which might be a cost that can't be overlooked when you're tendering a job, because a field review by an engineer might be a 15 or 20 or $30,000 component to the job. Alternative solutions, of course, like I said, when they're tendering the contractors also want truss suppliers to come up with more economical solutions. So you have to be careful when you're doing that to meet the engineering requirements from the building designers. Quite often we run into conflicts in capacity, for example, where an engineer might specify one beam that, an LVL beam, but when the truss designer runs it, they might find that it actually passes or doesn't pass. So how to deal with those capacities. So those things can get quite complicated, and it's where a lot of people get caught up where they don't quite read all the specifications, and at the end of the job, somebody says, well, you have to provide this engineering requirement or field review or something like that, and it's a hard thing to deal with. So again, knowing how to deal with those projects is very important. Supply chain issues. So I just want to touch on this. So especially like a lot of industries, we had a lot of supply chain issues after the pandemic started, with facilities not being able to supply things like even the metal connector plates, and lumber mills, being shut down, and engineered wood products companies, not being able to supply. But the main thing with supply chain issues is that communication has to be there. So if you have somebody ordering trusses through a lumber yard that's buying them through, in turn buying them from a truss plant, that communication has to be critical. And most issues we run into when there's a problem on a site are actually not necessary manufacturing issues. They can be more classified as communication issues. So what are their engineering requirements? How about installation reviews? Who's responsible for what? Making sure that the right building codes and loads are used. For example, in Alberta, we have mountain areas where the town of Banff has a particular snow load, but if you're building in a higher elevation, there might be a different snow load requirement. Some municipalities have their own guidelines when it comes to fire details and things like that, and it's important that all those things get communicated. Changes in plans, that's another thing where, contractors quite often send the plan in, and then the trusses get built, and nobody tells the truss manufacturer that there was a little change in plan. Even the stair opening changed a little bit. So those things all have to be communicated. Especially when you're reselling trusses, the shipping and installation information has to be communicated, is very important. So as I said before, truss companies are not building designers; they're component manufacturers, and a lot of issues arise where people, either the contractors or the homeowners or whatever, tend to rely too much on the truss company to design their building, which is not really the business they're in. So when you run into cases like this where, somebody, it happens particularly a lot in agricultural buildings. Somebody will just decide that they're going to build a riding arena and order up 65, 90-foot trusses and have them as cheap as you can. And this is really a red flag at for building suppliers and truss manufacturers, because there's no building designer on the job. So what that means is that when there's no building designer on the job, the owner has to take on a lot of responsibility. And you start running into things like designing for low human occupancy, minimum design capacity, people that aren't really qualified to install these large trusses, insurance requirements. Quite often, when you're designing or building these types of buildings, the owner will find that he won't be able to get insurance. And other things with these big farm buildings is we're seeing more and more is with more solar panels being installed. It's easy to look at a 300-foot long by 100-foot span farm building and say, look at all that real estate, let's put some solar panels on there. But the trusses were never designed for solar panels. So I just have this picture here. This is a farm building, long span trusses, and this is what we call top cord buckling, where even before the trusses are loaded, there's enough weight of the trusses themselves that top cord in compression can buckle, and you get a situation like this. So it's quite a scary situation when you get these large farm buildings where they're not bracing adequately or knowing how to install the trusses. So again, on farm buildings with no building designer, and here's another picture on the right where you can see these were about 90-foot trusses, and they installed the trusses one at a time, and you can see how this top cord is buckled here just under the weight of the truss itself. So this is farm trusses are a great application for these types of buildings, but there are some things that you need to consider. And when you're getting into long spans, you'll often get a warning on this that the truss erection and installation must be supervised by a professional engineer or other qualified person. And quite often that isn't done. It's the farmer or whoever is putting up the building themselves, and they just hire some people, and they don't really have the experience, which can lead to problems. In addition to that, when it comes to these farm buildings, it is still possible to design a farm building under the 1995 National Farm Building Code of Canada, which allows you to design for basically low human occupancy and make a bunch of other design considerations that can make the truss cheaper, of course, but obviously affect the capacity of the truss. So these are the buildings when we get this heavy wet snow like we're getting yesterday and today and tomorrow, that lead to collapses of these large farm buildings. Usually a lot of times when we do get this heavy snow like we're experiencing right now, it's not uncommon to have a collapse of a 100-foot riding arena or something like that was designed for low human occupancy. And basically, low human occupancy is in the farm building code means that there's going to be very few people in there, and if it does collapse, there's a low risk of you know uh, 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 injury to or death to human people. So when you are designing a building like this for low human occupancy, you know, just keeping that in mind. There is nothing wrong with designing a riding arena or a large ag building um, with a commercial design of trusses, which a lot of truss companies are doing now, just because the design is a little bit more, has more capacity and doesn't lead to these types of issues as much. So that's one thing to keep in mind. It, of course, adds a little bit to the cost of the trusses, but you get, you know, more substantial trusses. So farm buildings with no building designer. Here's another picture of one that, you know, a farm that was designed with low human occupancy. A lot of truss plants now, because there's no building designer, the truss plant is not the building designer. Might ask you to sign a supplement, basically saying that if you're going to design for this type of structure with these reductions in low human occupancy, that either the owner or the contractor take responsibility for making those design decisions. So you can certainly do it, but usually, you know, most companies that have experiences where they've supplied trusses and had this type of situation are now, of course, trying to limit their exposure where there is no building designer to actually make sure that the designs are correct. So truss installation, here's another example. So trusses are very efficient way of distributing load and spanning distances, but they are very unstable until they're braced. And it is important that the builder has to understand bracing, and also important that they understand that bracing can use a lot of wood. So here's just a picture of again some long span trusses, top cord buckling under compression. You can see that the first module of trusses they put up, and they just put even a little bit of diagonal bracing in there, and they stayed straight. When they loaded the other trusses up, there was no diagonal bracing in it, and the top cord buckled, ending up with a situation like this. So truss manufacturers do provide handling and installation guides that should be supplied with every truss order that goes through common braces. It's available on our web page, as well as there's a short video there on our web page talking about bracing the trusses. Here's what our installation guide looks like. So it talks about all the handling of the trusses and also bracing of trusses. So that is important that it goes with every page and or every job, and that the contractor receives that. So again, back to the supply chain issues, it's important that this information gets passed along to the contractor if you're reselling trusses. And this document has saved a lot of truss manufacturers where there have been failures due to lack of bracing, just by supplying it. So when it comes to bracing, there's basically three planes in a truss that we have to consider. The top cord bracing. So typically on a pitched roof, the top cord bracing is going to be provided by either the sheathing or purlins. But until that is applied, the top cord can be very unstable, like those pictures I showed you of top cord buckling. Here's an example of what we call a piggyback truss, where you have a truss that configuration that's too tall to ship. So it's basically built in two components, one with a flat top and then a triangular truss to go on top of it. And you have to remember that even on that flat top truss, that long top cord is in compression, so it's important that it be braced properly. And those 2x4s that are usually 2 feet on center are not that just there for spacing. They're bracing that top cord to ensure it doesn't buckle. And of course, they have to be restrained with diagonal bracing as well too. Web bracing is something that we talk about a lot, and you see it on the design drawings. So Here's some example in a typical truss. Usually, or the webs are either in compression or they're in tension. And when webs are in compression and they're not braced, they buckle just like a top cord will buckle. So you can see the picture on the right. Here's again a farm building that there was no continuous lateral bracing, and you could see a buckling here. And on the left is another picture of a line of web members that are all in compression with the bracing wasn't installed, and all those compression members buckled when the trusses were loaded. So that web bracing is a very important factor on the trusses. When you get the truss design, it might look something like this and have all kinds of bracing. So you can see here's the continuous lateral bracing, and here this web here has to have what we call an I brace on it, and this web here has to have a T brace on it, which is other members of lumber added to the web member to keep it from buckling. So it's very important that that bracing get put on as installed. Otherwise, those members can buckle just like in the previous picture. So there's typically a long run of trusses with the continuous lateral bracing. It's usually the most economical way to brace those web members. But it is very important when you have continuous lateral bracing to put these diagonal braces on here every 20 feet or as specified, because if you don't put those diagonal members on, then if the top cord of these trusses buckle, it'll just take all the bracing with it. So you need those diagonal triangles to resist that load along the run of the trusses. Here's some poor examples of continuous lateral bracing. So on the picture in the left, it's 1x4 bracing, which was the minimum, but it's not doing a very good job. And the picture on the right was a multifamily job where all the webs in the trusses didn't line up. So they just put a 2x4 between each truss. So that's not really acting as efficient bracing either. Here's a picture of using a 1x4, which you can bend a lot more to make the webs line up. But when you're doing this, it's not actually providing that resistance to those web members for buckling. And here's a correct way of doing it where those web members don't line up. So they've had to install T-bracing along the web members. And you can tell, obviously, guess in a situation like this, that can add up to a lot of lumber required for bracing. So that also has to be taken into account by the contractor. And then finally, the third plane of the trusses is the bottom cord bracing. So a lot of times there's a directly applied ceiling, but if there isn't, in the case of a farm building, you have to ensure that's braced as well. And there's just a quick little video here showing I took away the top cord so you can see how the bottom cord might be braced. And again, you see the diagonals in there to resist the load that bracing is creating. So basically, when it comes to bracing trusses, the standard saying is you have to brace the braces. So when you look at trusses, you're looking for a lot of triangles in the bracing. So you can see this is the Ronald McDonald House in Calgary, which is a commercial job. And you can see all the diagonals that the contractor has put here on the top cord, on the web members, on the bottom cord to provide that type of bracing. So you're always looking for those diagonals. When you're not looking up and seeing diagonals, it probably means that there's not enough diagonal bracing. And here's just a picture of a good job on a farm building. So you can see the diagonals to keep the trusses in place, bottom cord bracing with diagonals, and also the diagonals on the web bracing. So like I say, when you see those diagonals, you know that the contractor knows what he's doing when it comes to bracing. And here's just another example of a long span truss. You can see all the purlins were put along here. In this case, they had all their web continuous lateral bracing in here, but there was a lack of diagonal bracing and resulted in collapse of that building. So that's what could possibly go wrong. So, some of the things I just want to touch on again, I talked about long span trusses with top cord goes into the compression even before the truss is loaded. This was a job in Alberta where they lifted these trusses up with modules and with a big crane, and everything was okay until they set the trusses down, and the bearing of the trusses took the load, and the top cords immediately went into top cord compression just under the weight of the trusses. So this could have been avoided just with some simple diagonal bracing along supporting the top cord of the trusses and the web members of the trusses. Here's an example of a commercial job where they stood up all these quite deep trusses, a lot of mono trusses, and there wasn't any temporary bracing to hold the trusses in place, during installation, which is very important, and the trusses just dominoed over. Usually they say that there must have been a windstorm last night and knocked all their trusses down. But if you know how to adequately brace the trusses, you can have actually quite a large wind event, and the trusses won't collapse. So they always want to blame it on Mother Nature, but if you do a good job, it's not a problem. Here's another case of what was actually a commercial job outside of Edmonton several years ago that collapsed under snow load. And we came to find out that actually the person that built this own shop for themselves, ordered up trusses and basically said that it was a farm commercial building. In fact, it was a machine shop, and the trusses were designed as farm building code with all those load reductions that I mentioned earlier. And then they put a big storefront fascia on it that snow drift collected behind, and eventually led to the building collapse. So again, knowing what type of building it is and what the requirements are important. And here's another picture of another farm building that was a large span trusses collapsed due to top cord buckling that eventually got to the point where the trusses collapsed. So you can see in this case, the building collapsed. It was still under construction, so there was no sheathing on the roof. So it wasn't a matter of the snow overloading the building. It was just that simply, again, no diagonal bracing supporting that top cord from going into buckling that led to that collapse. But just about every time this happens, the first response from the building owner or the contractor is there must have been something wrong with the trusses. There must have been manufactured incorrectly or had some defects in it. That's always the first go-to. And when you're just looking at a big pile of wood on the ground, it's quite often hard to determine what the actual collapse was. But it wasn't. This case obviously wasn't a manufacturing error or anything that the truss plant did wrong. It was a farm building designed under the National Farm Building Code from 1995, and insufficient diagonal bracing in it. So those are some of the things that can go wrong. And again, it goes back to why that communication is so important all the way through the supply chain from the supplier to the end user. So hopefully I didn't go too quick there, so I'll open up for any questions.
Dave, I just want to say that was really, for me, that was really awesome. I've been to a couple of truss manufacturing plants. I've never actually got to see them being built, because any sort of build I've been on, they've already been installed and they all look good. But I guess one of my questions is, and you've touched on it a couple times on the communication piece, and if something goes wrong, it's usually the manufacturer that's where the finger is pointed. How do people get this knowledge of how it's supposed to be done properly at the end user? Where does that knowledge come from so that the installation can go according to plan?
Yeah, that's a good question. And that's why that installation information is so important. Hopefully, we would like to think that anybody that's installing trusses has experience putting up trusses, so knows these types of things. But even quite often I see in residential construction, you provide the installation information for, the diagonals and things like that. But quite often framers say, well, I've never done that before, so why should I do it now, right? And then they get into problems. Usually on houses, it's that type of construction where you're typically dealing with trusses that are less than 40 feet for most residential constructions. It's not as important. There's more repetitive elements in it. But when you get into those big, long spans, the bracing is crucial. So them understanding that installation information, making sure they get it. And then, like anything, like if you're going to be in that business, you should know how to, um, know what you're doing. I had one instance of a big farm building several years ago in Edmonton where, the farmer was building his own building, had these big trusses that he ordered up, hired somebody that said they had a lot of experience to install them, and actually tied the trusses down to big concrete blocks because he thought he was tying them down to prevent them from blowing away or falling over. And in fact, tying them down was loading the trusses, which put them into compression and led to their collapse. So it is an instance. Most residential framers are pretty good, but just because you're a residential framer on a house, it takes a different skill set than building 100-foot span farm building. And we do run into that quite often. And not only that, but a farmer building that 100-foot riding arena, um, you know, just hiring people off the street to put these up, a lot of times that's almost what we see. So when they tend to want to build it themselves, that's kind of a red flag.
Well, I'm going to be a little nervous going into a farm building these days after this webinar. So I have one more question. I don't know if anyone else has any questions, but in my short time in the industry, I've noticed in the last couple of years, there seems to be a lot more truss manufacturing plants popping up. I've noticed more businesses are adding this into part of their services. How do they find out about your organization and make sure that they're being compliant? Is it because they're going with the software? I don't know what that process is, but just trying to figure out where the knowledge gap there could potentially be minimized.
Yeah, I mean, like I said, it is a voluntary association, so there are a couple of trust plants that aren't members of associations, and sometimes I think that they might not be as knowledgeable. There is kind of a funnel where all to build trusses in Canada, you have to buy your plates from only one of three companies, so they're all involved with our association and know what our association does as well too. So that's a good way. Like whoever their plate supplier is should be whoever their plate supplier is most likely supplying them the design software and also has some liability there when it comes to somebody using their software and building trusses. So the software suppliers are all should be very keen on ensuring that their customers have quality management systems in place and things like that. So that should lead them to the Wood Truss Association of their region.
Okay, well, this was really great. I don't know if anyone on the line has any other questions. We'll give a little bit extra time here just in case, but if not, thank you so much for this, Dave. This was really great for us. I might follow up with a few resources that we could potentially even use on our educational resources as well, just to make sure people are connected. But this was really great. Thank you so much.
I would maybe, just on the last point, another issue is that we are, like yourselves, an advocacy group for the membership. So when it comes to dealing things with issues like building code issues in Alberta, we've had an issue ongoing for last a year and a half regarding stand data for what requirements are required from authorities having jurisdiction for engineering and sealing drawings and things like that. So we're also quite involved in those types of issues with, municipal affairs here in Alberta and building code issues and local authorities having jurisdiction. So like yourselves, I would say we're also an advocacy group whenever those type of things come up. Or
Okay.
builders want to be educated on installation and things like that.
Well, and I think one of the webinars we're doing with you is actually going to be focusing on the stand data as well. So I think Gary Fletcher had brought that to our attention. So we'll be looking forward to that one also.
But it's not resolved yet, so maybe when it is, then we'll do another
Okay,
one.
then we'll wait.
Okay, yeah, okay.
You give us the green light. Well, thank you so much for joining us. Thank you to all the members who tuned in today. I hope this was valuable for you. If you have any suggestions on future webinars that we should be hosting, please let us know, as we are here to connect members to information that is helpful to your day-to-day business. Dave, thank you so much. Appreciate your partnership, and we look forward to the next one.
Okay, thank you.
Have a great day, everybody.
Bye.
Bye.
Oh no, someone got the time wrong. She's trying to join now.